Hello! In this video I'm going to show you a streamlined method for solving polynomial inequalities. Your book uses graphing to do this section, but I'm going to show you a neat way to do it that generalizes, and you'll have to do this method in section 4.6, so I think it would be a good idea if you get used to doing it right now. And it's a much easier way to solve these problems than by graphing. The two problems I'm going to do with you are this inequality and this inequality. Just so you know what algorithm I'm following the following steps that you can see in section 4.6. Now I know it looks a little intimidating, but don't worry, I'm going to break down each step with you by going through the examples, and I think it will be clear if you go back and read these directions later after you watch the video. This will all make sense. Okay, so our first problem, solve the following inequality. X squared plus x is greater than 6. Step 1, move all the terms to one side. You can use the left-hand side or the right-hand side. I usually move all the terms to the left, and I call that LHS for left-hand side. The important thing is you have 0 on one side, and we've got that. Step 2, factor the left-hand side. Once it's factored, you can use the zero factor property to determine where the left-hand side is 0. So I factored x squared plus x minus 6 pretty easily, x plus 3, x minus 2. Now the original inequality is that is greater than 0, and from now on I'm going to call that my original problem because it's a different form, but that's the problem I'm solving. However, the second step is to see where that expression is 0. So I set that polynomial equal to 0, and I see I get 0 at x equal negative 3 and positive 2. Negative 3 and positive 2. Those are the two numbers I'll use in the next step to plot on my number line. Alright, so step 3, you make a number line and you plot those numbers that you got from step 2. Step 4, those numbers divide the number line into intervals. The first interval is negative infinity to negative 3. The second interval goes from negative 3 to 2. And the third interval goes from 2 to infinity. So those are my three intervals. I want to pick a test number from each interval. And then I'm going to determine whether this expression on the left here is positive or negative at each test. And then I'll draw my conclusions from there. Alright, so the test numbers you pick are totally up to you, that you can pick any number from each interval. I usually pick the smallest or easiest number to work with. For this first interval, I chose negative 4. For the second interval, I chose 0. And for the third interval, I chose 3. The only numbers you can't pick are the actual numbers that divide your intervals. So you can't pick negative 3 or 2, but you can pick any other number. So those are the numbers I chose to pick. Now what I'm going to do is plug those numbers into the left-hand side of this expression to see whether I get a positive or negative. And so let me show you what that looks like with the first interval. My test number is negative 4. When I plug that into the left-hand side up here, I put negative 4 into x plus 3, x minus 2, and I get negative 1 times negative 6, which is 6. That's one way to do it. I think an easier way, since you don't really care what the number is, you just care whether it's positive or negative, I just look at the sign of each of these factors when I plug in negative 4. If I put negative 4 into this first factor, I'm going to get a negative number. If I put negative 4 into this second factor, I'll get a negative number. 2 negatives is a positive. That's all I care about. Is it positive or negative? Don't really care whether it's 6 or not. So that's a quicker way to do it, is just to look at the plus minus. Let's look at our next two intervals. When I put 0 in to x plus 3, x minus 2, I get 0 plus 3, which is a positive, 0 minus 2, which is a negative. A positive times a negative is a negative. And for my third interval, I put 3 in. 3 plus 3 is positive. 3 minus 2 is positive. Positive, positive gives me a positive. Now what do I do with that? I put those pluses and minuses over my intervals in the number line. So I put a plus over the first interval, a minus over the second, and a plus over the third. Finally, to give my final answer, I have to look at the original inequality and I have to see whether I want the positives or the negatives. Since this is greater than 0, I want the positives. I want the places where the expression is positive. So I want the first interval and the last one. And it's as easy as that. Let me show you what your answer would have been if the problem had been a little bit different. So this is our problem. But if the problem had been solving x plus 3 times x minus 2 greater than or equal to 0, then I would not only want the positives, but I would want these numbers here, these dividing numbers, because this is where the expression was 0, at -3 and at 2. So I want to include those in my solution interval, so I'd have a square bracket at the -3 and a square bracket at the 2. I should mention, infinity and negative infinity always get a round bracket by them, always. Okay, if the problem had been the left-hand side strictly less than 0, then we'd be looking for the negatives, and we'd go from -3 to 2, and we would not include the endpoints because it's strictly less than 0. Finally, if it had been less than or equal to 0, then we'd want the negative interval and we'd want to pick up the 2 endpoints. So we'd have a closed interval from -3 to -2. All right, let's do one more problem that's a little bit different. We're going to solve the following inequality: x squared minus 3x plus 7 less than or equal to 0. We're going to solve it the exact same way. Don't worry, it'll go a little quicker. Step 1, move all the terms to one side. I think they were already on the left-hand side anyway, but that step is done for us. Then we try and factor. When we try and factor x squared minus 3x plus 7, it's not so easy. So one way to factor is to use the quadratic formula. The quadratic formula would solve where this expression is equal to 0. If you've forgotten it, here it is, negative b plus or minus square root of b squared minus 4ac over 2a. My a is 1, my b is -3, and c is 7. I put all those numbers in, and I see that I do not get a real root. The square root of -19 is a complex number, so that means that there are no x-intercepts. This is, if we graphed this parabola, it would never intersect the x-axis. So there are no points to plot on the number line. Here's my number line. There's nothing to plot. Okay, that's all right. It makes it easier. I only have one test interval from -infinity to infinity. I just have to pick one test number and I'll be done. So my chart looks like this. My interval goes from -infinity to infinity. I chose 0 as a test number. I put 0 into the left-hand side and I get 7, which is a positive number. So I put a plus over my number line. And then I go back to the original inequality and I say, well, what did I want? Did I want positives or negatives? I wanted negatives plus 0. So there is no solution. It's the expression on the left is always positive, so it will never be less than or equal to 0. If the original inequality had been turned around, greater than or equal to 0, then every number in this interval would have been a solution, and my solution would have been -infinity to infinity. Geometrically, what's happening is that the left-hand side here is a parabola. If you graph y equals x squared minus 3x plus 7, you get a parabola, and it would lie completely above the x-axis. It would never go below the x-axis. All right, so I'll do more problems like this in section 4.6, and that video will start off with some polynomial inequalities like this, except a little harder, and then some rational inequalities. Hope this helps. Bye.